Gravitational field, same as that of electric field, you can define the space around a mass in which another mass experiences the gravitational force. So gravitational field is the gm divided by d square. So today we will discuss very one of the important aspect of the gravitational field and the electric field. Basically we will compare the strength of the gravitational field and the electric field. Okay, so the strength of, don't write, okay, first listen, then I will give you the time to write. Okay, the strength of gravitational and electric field Okay, so if I am just asking, suppose I am having a charge here q, and at this point p, which is at a distance of suppose d, I want to find the strength of the electric field, then what will be the formula? Electric field is equal to kq by d square.
Okay.
Kq by d square. So you can say that the electric field is also inversely proportional to d square, means this electric field is also following the inverse square law. Okay, so this is about the electric field strength. Okay, this is about the electric field strength. Just wait. Okay.
Yeah.
Electric field. Just wait. Now here I am just defining the gravitational field. We have already defined this. So gravitational field. So I am having a mass m here, and at a distance d, suppose at a point q, if I want to find the gravitational field, how I will find? What will be the formula? I have told you. Definition, you know, the space around the mass in which another mass experiences the gravitation. That is okay. Tell me, just tell me.
G m1 m2 over d squared.
No. See, due to this mass, the strength of the gravitational field at this point q, okay, will be g into m divided by d square. Simple.
Okay.
We have discussed now in the last class. See, E is equal to kq by d square. G F is equal to gravitational field is equal to gm by d square. So basically, gravitational field is also following the inverse square law. Okay. So basically, we will now see the variation of the electric field and the gravitational field with distance. Okay. So initially, this is the electric field. Suppose now same charge I have taken. This is example number 1. Same charge I have taken. Charge Q I have taken. Okay. Charge Q I have taken, and now this time this point P is at a distance of 2d. This point P is at a distance of 2d. So we will see what will be the value of the electric field strength at this point P. So we will apply the formula. E is equal to K into charge divided by the distance square. What is the distance this time? 2d square. So this is 2d square, means it will become 1 by 4th of, okay, basically it will become kq divided by 4d square. So I can write it 1 by 4th of kq by d square. So kq by d square is E. So kq, so basically suppose this is E dash. So the electric field strength become 1/4. Electric field strength becomes 1/4 when the distance becomes double. Suppose for example, if I want to find, suppose this is a charge, and at this point I want to find the electric field strength at this point. So this time suppose the distance is 1 meter. Okay, so suppose the electric field strength, I am not talking about the electric force, I am talking about the electric field strength. So electric field strength at this point will be, suppose E. So suppose I have increased the distance, it will become 2 meter. Now you have doubled the distance, but the electric field strength become 1/4. Okay. Same is the case for the gravitational field. You have a mass m here, and you have now the point q at a distance of 2d. And what will be the gravitational field? Gm divided by distance square. So it will also become 1/4 time of the initial gravitational field. Okay. So this is the way. Okay. Okay. After that, we will now compare. Which force is greater, electric force or the gravitational force, or which field is stronger, the gravitational field or the electric field. So I will prove that which field is greater. Okay. With the help of one very beautiful example I will take, and we will prove that.
Okay.
So before that, there is a note point. There is a note point in physics. Inverse square law. Stating that a specified physical quantity or intensity is inversely proportional to the square is to the square of distance from the source of that physical quantity. So what does it mean? I have already explained you, but just for the interest of physics, again I am telling, suppose here is some suppose at this point P, okay, at this point P, I want to find the intensity of some physical quantity. So here is some physical quantity. Okay, here is some quantity or physical quantity. What is the meaning of the physical quantity? The quantity which is measurable. Measurable quantities are known as the physical quantity. You can take the example of electric field also. You can take the example of, suppose, electric field you want to find at point P. So we know that the electric field follow the inverse square law. it will, suppose this is the distance d, so this will become d square. So you can say intensity of electric field will be inversely proportional to the square of the distance. Okay, this is just the example. Okay, now we will compare the gravitational force and the electric force. So do you have any idea which force will be greater, electric or gravitational force? Gravitational. Okay, so we will see which force will be greater. You are saying gravitational force. Okay, so now we will compare comparison of gravitational and electric force. Okay, for the comparison, basically what I am taking a electron and I am taking a proton. Okay, for the comparison purpose, I am taking a electron and I am taking a proton. So this information you should have of the electron and the proton. The information I am writing here, you should have. So basically, okay, so electron and proton, and here is the charge on electron, here is the mass on electron. Okay, so this is the electron, this is the proton. So charge on electron is minus 1.6 into 10 to the power minus 19 coulomb. Charge on the proton is plus 1.6 into 10 to the power minus 19 coulomb. Mass of the electron is 9.11 into 10 to the power minus 31 kg, and mass of the proton is 1.67 into 10 to the power minus 27 kg. So can you tell me the mass of the proton is greater or electron is greater?
Proton.
Yeah, of course. Because here is 10 to the power minus 27. Here is 10 to the power minus 31. So basically, this power is greater in minus, means the whole value will be less. So basically, what is this? This is the mass or a charge on proton. Charge on proton. Basically, what is this? This is the charge on electron. Basically, what is this? This is the mass of electron. This is mass of proton. Okay. First, we will see what is the electric force between the electron and proton. First, we will see the electric force between the electron and the proton. So basically, we have one electron here and we have one proton here. So electron I am representing with E, proton I am saying P. And distance between the electron and the proton is D. See, this is very important means concept. Okay, so electron and proton are there separated by a distance D. Okay, so this electron will have a mass and will have a charge also. Okay, so first we are calculating the electric force. So Fe is the electric force. So if I will calculate the electric force, so here is the electron, here is the proton. So there will be the charge on the proton. Here is electron. So here charge on electron and charge on proton. Is it or not? So basically we know that the electron and proton are of opposite charge. So they will attract or repel? They will attract each other?
Yeah.
They will attract each other with the electric force. Now we will calculate the electric force. How we will calculate the electric force? Formula we have K Q1 Q2 by R square. K into Q1, you can take this as Q1. You can take this as Q1. You can take this as Q2. So K Q1 is charge on electron. Charge on electron, charge on proton divided by the d square. So K is 9 into 10 to the power 9. See here. Charge on electron is 1.6 into 10 to the power minus 19. Charge on proton 1.6 into 10 to the power minus 19. You will say that why I have not taken here the negative charge. Because direction we have already decided. Okay. We have already decided the direction. The force will be attractive force. Okay. So that is why I have not taken here the negative sign. I have earlier also told you when we were discussing that your assignment. Okay. So in the denominator we have the d square. Now we will calculate this value. So when we will first we will multiply the numbers. This is 9. This is 1.6. This is 1.6. 1.6 multiplied by 1.6 will be 2.56. And when you will multiply this, you will get 23.04. 23. Just you can calculate by your calculator also. Yeah. Just check this. Check this.
What do I say?
You have to 9. First, you will multiply only number.
Yeah.
This is 10 to the power 9 and 10 to the power 19, and this 19 we will calculate later.
Yeah, it's 23.04.
Yeah. Now, what will be the power calculation? Here 10 to the power 9, here 10 to the power 9, here 10 to the minus 19, here 10 to the minus 19. So what you will do? Minus power you will add. Minus 19 and minus 19 is minus 31. Okay. Yeah. It will be minus 31. In power we are calculating. And here is plus 9. So here is plus 9. What will be what you will get? You will get 29. So basically you will get 10 to the power 29 divided by d square. So basically this will be the electric force between electron and proton. Electric force between electron and proton. So basically this is the electric force. Okay. So this is the electric force. Now we will calculate the magnetic force on electron and the proton. Okay. And then we will compare which force will be greater. Okay. So for the magnetic not magnetic force, gravitational force we will compare. Gravitational force. F suffix G is the gravitational force. Okay, so basically here will be the electron, and at a distance when we are comparing something, so we will take some parameter same. So distance I am taking same between the electron and the proton. At the same distance we are calculating the electric and the gravitational force. So here is electron, here is proton. So there will be the mass of the electron and mass of the proton. So here mass of the electron and mass of proton. Okay. So I have told you the gravitational force is always attractive. So both will attract each other, electron and proton, due to the gravitational force. Fg. Now for calculating this value of the gravitational force, we will apply the formula G m1 m2 divided by d square. So G into m1 is mass of electron and mass of proton divided by d square. So force of gravitation will be value of the G 6.6. Tell me the value of G.
6.67 times 10 to the power minus 11.
Yeah, minus 11. Mass of electron, we can see here mass of electron. Mass of electron 9.11 into 10 to the power minus 31 kg. So this is 9.11 into 10 to the power minus 31 kg multiplied by mass of proton. So mass of proton is 1.67 10 to the power minus 27 kg. Okay. So it is 1.67 into 10 to the power minus 27 kg, and this is d square. This is d square. Now we will multiply first 6.67, 9.11 into 1. Do this by yourself with the help of calculator.
Okay.
So basically you will get this value 101.47. I think no. Yes. You will get 101.47.
Um,
Hmm. 6.67 multiplied by 9.11 multiplied by 1.67. See.
One hundred and 1.47.
Now, can you do this power calculation?
Yeah.
See, tell me what will be the answer for the power calculation.
Times 10 to the power minus 69.
See how 69. This is 11 in minus. This is minus 31, and this is minus 27. So you will add all the power. 7 plus 2 9, and this will become 6 minus 69. So basically 10 to the power minus 69 you will get, and this is in Newton. So and divided by d square. Divided by d square. So okay, so here just a minute. So basically this is the gravitational force between the electron and the proton. So what is this? This is the gravitational force between electron and proton. Note down this, then we will compare the values and we will see which force is greater. You can ask me to scroll down, okay, when completed. Just note down.
Sir, can you scroll down? Hmm. Sir, can you scroll down? Okay, sir, I'm done.
You told me that gravitational force is more stronger than the electric force. So we will compare. So I am supposing this equation as equation number 1. Okay, now see, I will give you again time for noting down. So this is equation number 2. So now I am just dividing this equation number 1 by equation number 2. Okay, so I am dividing the equation number 1 by 2. So dividing equation 1 by 2. So how we will divide? See the equation number 1. Fe on the left hand side we have Fe, and on the left hand side of the equation 2 we have Fg. So first we will divide Fe divided by Fg. On the right hand side of equation number 1 we have 23.04 into 10 to the power minus 29. This is minus basically. Okay, 23.04 23.04 into 10 to the power minus 29 and divided by d square, and this will be divided by the gravitational force, this value.
Yeah.
101.47 into 10 to the power minus 69 divided by d square. Now see here, this d square will be cancelled out with d square. So we will have 23.04 into 10 to the power minus 29 divided by 101.47 into 10 to the power minus 69. Now what we will get? See, I can write this as 230.4 into 10 to the power minus 30. Can I write this? This equation, this upper part means the numerator. In denominator we have 101.47 into 10 to the power minus 69. So we will get this value. So when you will divide this 230.4 by 101 by, okay, then you will get 2.270, okay, and this is 10 to the power minus 30. In divide there is 10 to the power minus 69. So how you will do the calculation? Like this, na? This is minus 30 and plus 69.
Yeah.
You will get 39 again.
Yes.
You will get 39, na?
Yeah.
You know, na, how to calculate the power calculations.
Yeah.
Okay. So basically this much you will get 10 to the power 39. 10 to the power 39. Now can you tell me which force is greater? See here. Okay. Just I'm giving one more example. Suppose I am saying A divided B is equal to 25. So which one is greater? A is greater or B is greater? So I can say that this as A is equal to 25 times of B. A is equal to 25 times of B. So which will be greater? A greater or B greater?
A.
Yeah. Same concept will be applied here.
So FE is greater.
Is equal to 2.27, not greater but very much greater. 10 to the power 39 times of the gravitational force. See, this electric force is much greater than the gravitational force. You can see here. Okay, so this is basically your electrical force is much greater than the gravitational force, and in value it is 2.270 into 10 to the power 39 times of the gravitational force. So basically you can say that the electric force is much greater than the gravitational force. We can say that.
Yeah.
Okay, now there is one more topic here. If we will compare the constant of the electric force and constant of the gravitational force. So in Coulomb's law, we have seen that uh, suppose if I want to just comparison of magnitude of Coulomb constant and gravitational constant, universal gravitational constant. So we know that the value of the Coulomb constant K is 9 into 10 to the power 9, and value of the gravitational constant, you can say universal gravitational constant, 6.67 into 10 to the power minus 11. Which one is greater? K is much greater than G.
Yeah.
So you can say that here these constants are also responsible for that the electric force is greater than the gravitational force. Because what you are doing here, basically when you are calculating the electric force, see, when you are calculating the electric force, so you are multiplying something which is very greater, and when you are calculating the gravitational force, you are multiplying something which is smaller, very small. So it means that the gravitational, from the gravitational constant of the electric force and the gravitational force, we can conclude that the gravitational force is weaker, much weaker than the electric force. Okay, so I can write one point here. So this is an indication. This is an indication that strength of two forces. So you can say that again, electric force is much greater than the gravitational force. I am writing just, so I have already written here. Okay, just for case if you are not getting what is this Fe and Fg, so I am writing again here. So you can say that the electric force is much greater than gravitational force. So you can compare the gravitational force, gravitational field and the electric field also same. The formula will remain same. Means you can say that the gravitational field is much weaker than the electric field, or electric field will be much stronger than the gravitational field. Okay, why? Because the gravitational force is much weaker than the electric force. Okay, so now you can note down from here.
Okay.
Got it now?
Yeah. Sir, can we end like if we're done, like, get my, I think it's something wrong with my laptop because like the fans, they've been going on high.
Okay.
Yeah.
So what do you want? What should I do?
Like, can we end at 8:30?
Of course, no problem. So you can note down in the next class these things. If
Yeah,
your laptop, if
yeah,
your laptop.
I'll see how much I can note down right now.
Okay, no problem. If your laptop is heating na,
Yeah.
so the processing will become slow due to that. I know that. So you okay? So you can leave here the class. No problem. You can
So
note down.
I'll just take screenshots and note it down later.
Okay. You can take the screenshots
Yeah,
from here,
can you scroll
and
down?
you can scroll down.
Yeah.
Okay. So you can just complete this in your copy. Okay.
Yeah. Okay.
And before coming to the next class, revise your notes, and just I am sharing my screen. I want to show you something. Basically, just wait for 1 minute.
Yeah. Okay.
So see this. These are your notes now. These.
Yes.
So basically, na I have completed this part. So in the next class, we will discuss this ocean tides and these all things. Okay.
Okay.